So my student, the last class basically it was based on steam properties, and today we will see some of the mathematics. And you know the first thing that comes that definitely what is steam. We all know that steam is the gaseous form or vapor form of water. We basically use boiler to make steam. This diagram we have already discussed, the TH diagram. Okay, already we discussed in the last class. And there are two types of heat we also discussed. That one is sensible heat, one is latent heat. In the sensible heat, we know that, sir, the temperature change, but phase constant. Phase constant means, my student, the phase of the particle of the material, the state. That means if it is liquid, it will remain liquid. If it is solid, it will remain solid. So that means constant. There is no change of phase, but the temperature will change. That means the 30 degrees Celsius of water will after getting this sensible heat, it will become, suppose, 70 degrees Celsius of water. So you can see the temperature is changed from 30 degree to 70 degree, but phase constant, water remains water. This is sensible heat. And what is latent heat? We discussed in the last class, but still, the latent heat, the phase changes but the temperature constant. That means now the phase of the particle of the material will change. The solid will become liquid, the liquid will become gaseous form. Okay, so the phase changes but the temperature will remain constant. How? You see that when the 0 degrees Celsius of water, the 0 degrees Celsius of ice convert starts take heat, it first becomes 0 degrees Celsius of water. So the temperature is 0 to 0, but you can see the solid has become to liquid. That means the phase of that particle, the material, is changed. In the similar way, 100 degrees Celsius of water starts to boiling and it becomes 100 degrees Celsius of steam. So you can see that 100 degrees Celsius remain 100 degrees Celsius, but the phase changed. It liquid becomes gaseous form. So that is latent heat. So remember, these two things are very important. And the total heat of a system we discussed in the last class, that is enthalpy, and we represent that with H. The total heat of a system, H, is equals to sensible heat, the amount of sensible heat, plus addition latent heat. Always remember, you can take some side notes, that the total heat of a system, that means the enthalpy, the total heat of a system, that is enthalpy, equals to the sensible heat, the amount of sensible heat in the system, plus latent heat. Always remember. Okay, now a very important factor is come. Is Shuaib is here? Shuaib, can you listen me?
Yes, sir. I'm listening to you, sir.
Okay. If I tell you that, Shuaib, can you explain the dryness fraction to all of us? Can you? Or you can try, just try.
Yes, sir. We can explain, sir.
Yes, please.
Sir, in someone language or English language?
English will be better. I will understand. Also, some of the Bengali students will understand.
Okay, sir. In this, sir, dryness fraction, sir, is the ratio of the weight of the actual dream stream that will weight some quantity of the wet stream. Sir, in this time, dryness fraction, sir, is the number of the water is will be changed from the steam. How much what is steam that will be changed in the dry steam, sir? So that should be X. So that's the
Yes.
dryness fraction, sir.
Okay, so whatever he's telling is absolutely right. That's the dryness fraction is a ratio. It is a ratio. So why it is needed? First of all, that is the interesting thing. That's why it is needed. It is needed that, my student, you all know that the TH diagram, there is a flat region of wet steam. There is a region. After the region, there is a one point of dry steam. then we make the superheated steam. So for that wet steam, it is a region. Okay, so we cannot tell that how much the wet steam has converted. Okay, so to tell that, we invented, or the scientists invented, a new parameter, that is dryness fraction, or commonly known as quality of steam. Okay, so using that parameter, they can identify that where the water is situated, where the dryness, steam is situated, wet steam, because there is a region. The point can be anywhere, but how can we understand the point? So they denoted a new factor that is named as dryness fraction, X. Remember, the dryness fraction is only for wet steam. Remember, the dryness fraction is only for wet steam. So they actually, what they have done, suppose we can explain it to two way. That suppose we can go to the first of all, the dryness fraction value is between two. Suppose if the X is the dryness fraction, you can take some notes. The dryness fraction value is greater than X, my student, and less than 1. Okay, so that means the value will be in between 0 to 1. So suppose I take the dryness fraction value is 0.9. Now the question is, what does it means? What does it means that X equals to 0.9? So it means, my student, remember that if I take 5 kg of water, 5 kg of water in a pot, and starts to heat, okay, after some time it will, the steam will start to begin. We are getting steam after 100 degrees Celsius. So that means at a fixed time, all the water will not convert to steam, my student. All the water will not convert to dry steam. So at first, some portion of water will become steam. Then after that, some portion of water will become steam. So this dryness fraction gives us the concept that how much water has converted to steam. So when X equals to 0.9, remember, that means if you multiply with 100, it will be 90. So from 100% of water, 90% of water has become steam. So basically, my student, the idea is, I have gone so many things. The idea is, whenever X equals to any value, suppose X equals to 0.5, if I take 1 equals to 100%, if I take 1 into 1 equals to 100%, so 0.5 equals to 50%, that means 50% of water has converted to dry steam, and remaining 50% of water is still left on the pot or wherever we are making the steam. So that's why it is a ratio. Basically, it is a ratio of how much steam has converted to dry steam, and divided by the total amount of water it was. Okay, so that's why the value of X is always a ratio. Okay, and it gives us that how much steam has converted, how much steam has converted, because in wet steam we know that all the water do not convert steam at the same time. Okay, so in Bengali, যে dryness fraction একটা রেশিও, যে রেশিও থেকে আমরা বুঝতে পারি সেটা হলো যে কি পরিমাণ পানি আমার বাষ্পে পরিণত হয়েছে। তাহলে এই ভ্যালুটা হলো 0 থেকে 1 এর মধ্যে। যদি মনে করো এই ভ্যালুটা 0.9 হয়, তাহলে যদি এটাকে আমি পার্সেন্টেজে নিয়ে যাই, তাহলে 90%। এটা কিসের 90%? 90% হলো আমি যতটুকু পানি নিছিলাম তার 90 ভাগ আমার ড্রাই স্টিম অলরেডি কি কনভার্ট হয়ে গেছে। তার মানে 10% কি বাকি আছে। যদি এটা হয় 0.3, তার মানে 30% স্যার স্টিম কনভার্ট হয়েছে, আমি স্টিম পাইছি বাকি 70% এখনো কি পানির অবস্থা বা লিকুইড অবস্থায় আছে, সেটা এখন স্টিমে কনভার্ট হয় নাই। ক্লিয়ার? এবং ড্রাইনেস ফ্র্যাকশনটা শুধুমাত্র এই ওয়েট স্টিমের জন্যই প্রযোজ্য। So that was the dryness fraction. Is it clear, my student, everyone?
Yes, sir.
Okay. So it is only for wet steam, remember. Okay, only for wet steam. Okay, my student, one more thing, that's now the equation development. Okay, the equation development. So we have to develop equation. We know that there are two types of heat. There are two types of heat. One is sensible heat, another one is latent heat. First of all, the sensible heat, we all know this comes from temperature change, isn't it? It comes from temperature change. So the sensible heat, basically, if I take the heat is Q, the sensible heat is equals to, you remember this equation, this is calorimetry equation, MS del T. Can anyone remember this?
MS del T.
This is your higher secondary level equation, MS
Yes.
del T, the heat equation, where M is the mass, S is the specific heat,
Specific.
and the del T is the
Change of
temperature change. Remember?
Yes, sir.
In Bengali, তোমরা কি তোমাদের মনে আছে 19 এ ক্যালোরিমিটার সূত্র, এটা ms del T
Yes, sir. Yes,
তাপের
sir.
সূত্র ছিল এটা। Okay, my student, from now we will consider the mass m equals to 1 kg from now on, because in coming slides, already I have given this class lecture. Whatever I'm discussing, I have already discussed on that video, and I have given. So I have given that if you somehow see that video, and then come to my class here, it was very easy. It was very easy. So you lost an opportunity. So from now on, we will consider m equals to 1 kg, and S is the specific heat, my student. The specific heat, or in Bengali it is apekshik tap. For water, the specific heat is 4200 joule. Am I right?
Yes, sir.
For water, it is 4200 joule. That means we can take it 4.2 kilojoule, isn't it? Yes, we can make the 4.2 kilojoule. Okay, so we got m, we got s. So what is del T? Del T is the temperature difference. Suppose we start from the 0 degree Celsius and we give heat, and now we make the temperature T degree Celsius, suppose. So what is the temperature difference? This is the highest temperature, this is the lowest temperature, my student. So what is the temperature difference? It will be
E minus 0.
T minus 0. So basically it will be T. Okay, so in the same manner, my student, m equals to 1, s equals to 4.2 kilojoule, and del T equals to T. So if I give all this value here, so here you can see that mass into sp into del T, 1 kg mass equals to 1 kg, sp specific heat,
Sir,
yes,
sir, 4.2 kilojoule per kg per Kelvin.
this is specific heat. Should I tell what is specific heat?
No,
Kadi?
sir, I know that.
Okay, the specific heat basically that for 1 kg of water, if you want to increase the temperature of 1 degree Kelvin, then you need 4200 joule of heat energy. That is the specific heat, my student. Okay, and the temperature difference. So finally we get, my student, 4.2 T kilojoule. Okay, 4.2 T kilojoule. So that we got the derivation, the sensible heat equation, 4.2 T kilojoule. So basically here we only need the temperature difference. After that we can easily tell what is the sensible heat. Clear? And for the latent heat, my student, is very interesting. that you can see that the latent heat is basically related to the dryness fraction. Why? Because here it is the starting point, boiling point, and it is the end point. So here this point is water and this point is full steam. This is full water, this is full steam, but latent heat is required to convert this water to steam. So when you convert the whole water to steam, you get the total, latent heat. But if you are here at this point, suppose x, this point is x and x equals to 0.6, that means your 60% water is converted to steam. So that means the total, suppose the total latent heat is 600 joule, suppose, and x equals to 0.6. What does it mean? It means that your this 600 joule is when you convert your total water to total steam, then 600 joule is required. Okay, but your x equals to 0.6, that means your 60% of water has converted to steam. So will I require 600 joule or less, my student? Probably
Can
not.
I agree, sir?
Probably not clear. Suppose 100% of water, if I convert this 100% of water, suppose it may be 2 kg, it may be 5 kg, it doesn't matter, but I'm considering all amount of water. If I convert 100% of water to 100% steam, then I require 600 joule. But I am told that your dryness fraction is 0.6. What does it mean? It means that have your 100% water converted to steam? No,
No,
No.
sir.
only
60%.
60%,
Only 60%.
isn't it?
Yes, sir.
So now, should I require 600 joule or less amount of heat?
They require 600.
For to get 60%, should I require 600 or less?
Yes, sir. We require 600.
No, my student. 600 is for 100%.
Oh,
Sir,
sorry.
not
It will be less, sir.
But for
It's 400.
60%, it will be less.
yes, sir.
So 600 divided by 100 into, but multiplied by 60. So if I, take, if I cross this, it will be 360 joule. Am I clear?
Yes.
360 joule. So that's why the latent heat is depend on dryness fraction. So whatever the latent heat, we will know the total latent heat, but we will see that what is the dryness fraction. Where if the dryness fraction is 0.6, then we will multiply with the dryness fraction. If the dryness fraction is 0.7, we'll multiply. See, when the dryness fraction is 1, my student, that means, what does it mean? Can anyone tell me?
The 100 percentage of the water can boil 100 joules, sir.
Yes. So at that time, we will multiply with 600 with 1. So it will be 600, isn't it?
Yes, sir.
So it is totally depend on the dryness fraction. So remember, always remember that it is very easy that the latent heat is, multiply with the dryness fraction. Okay. And the sensible heat is 4.2 T kilojoule. Now we will represent the total heat of the system for both 3 steam: wet steam, dry steam, and superheated steam. Okay, so it will be very easy. See, let's see that suppose here a particular point, suppose this is the 0 degrees Celsius of water. See, this is 0 degrees Celsius of water. If I give heat, it will become 100 degrees Celsius, isn't it?
Yes, sir.
100 degrees Celsius, or it is boiling point, isn't it? At this point, the water boils. So we can tell it TB, the temperature of boiling point. After that, if I give heat, the steam starts to convert. So at this point, all the water has converted to steam, but the temperature is still, my student, the temperature is still boiling point temperature, because 100 degrees Celsius of water converts to 100 degrees Celsius of steam. Okay, but after that, if I give more heat, my student, if I give more heat, this becomes superheated steam. The temperature is Ts. Okay, so here this region is wet steam. See this, please see this wet steam. This point is dry steam, and this point is superheated steam, isn't it? So my student, we will represent the equation, three equation for wet steam, dry steam, and superheated steam. Before that, we need to identify which heat, because from 0 to 100 degrees Celsius a heat is required, and which heat it is. Is it sensible heat or latent heat? Can anyone tell me?
So sensible.
This is sensible heat, my student. Good, very good.
Sensible heat, sir.
From 100 degrees Celsius of water to 100 degrees Celsius of steam, which heat it is?
Latent.
This is latent heat. Excellent. And for TB, or the boiling point dry steam, to superheated steam, here temperature is also changing, so this is also sensible heat. Clear? This is also sensible heat. Okay, now my student, we represent sensible heat is with HF. Sensible heat is SHF, and latent heat is HFG. This is just the variable, nothing else. There is no rocket science. HFG. Okay, S equals to HF. That means sensible heat we will represent by HF, and the latent heat we will represent by HFG. And the total heat of the system, we know that that is enthalpy, that is represented by X. So my student, you can see here the three equations for this three steam. How? First of all, the wet steam. Wet steam, we all know that this is the region of wet steam, and here any point is the dryness fraction. Suppose this point is the dryness fraction. So to come here, to come this point, to come here, my student, we will require two types of heat. To come in this point, suppose I'm marking with the blue color, to come this point we require two heat. One is this this sensible heat, another one is this amount of latent heat. Okay, so the total sensible heat, you see that we know that the HF, and the latent heat we just studied that it is multiplied with the dryness fraction. So you can see that the XFG. So the equation for the wet steam is that the sensible heat plus XFG. Because why it is X? Because it is not fully converted to the steam. Some portion of water has still remained. So that's why it is multiplied with the X, the dryness fraction. But for the dry steam, I remember, for the dry steam, if I erase this point, okay, for the dry steam, this is the point, my student. Here all the steam we get, here no water is left, so we get whole steam. So the total dry, the total sensible heat will be, and the total latent heat we need to calculate. So to get this dry steam, the total heat of the system will be the total sensible heat and the total latent heat. So that's why you can see the dry steam, the HF, the sensible heat, and the HFG, the latent heat. This is the equation for the dry steam, my student. Now the question is for the superheated steam. First of all, you have to come to this this dry steam, then you will get the superheated steam. So for the superheated steam, we have an extra portion. This portion we have to calculate with the dry steam. Okay, so this portion is sensible heat, isn't it? Sensible heat. So we studied the sensible heat equation, ms del T, isn't it? Just before. ms
Del T.
del T. And we also told that the value of m is 1 kg. The value of ms is 1 kg. So s is sensible, specific heat, s or cp, whatever. This is specific heat. Okay. And then the temperature difference. The temperature difference is, one is Ts, another one is TB. So the difference is Ts minus TB. That means T super minus T boiling temperature. Okay, so this is the equation for the superheated steam. Here Cp is the specific heat. You can write this S also. It's not a big deal. Is the representation, nothing else. And why we are missing M? Because we are taking the value of M is 1 kg. Clear?
Yes, sir.
So this is the three equation for the wet steam, dry steam, and the superheated steam. Don't worry, my student. It is very easy. When you go to the example, it will be very easy. Suppose here. Okay. Always remember the dryness fraction is related to the wet steam. Wet steam. When no steam will be told to the example or in the question, you have to consider that it is if the dryness fraction is given, it is wet steam. You see that here, my student, the example at P equals to 10 bar, that means pressure. At P equals to 10 bar, that means pressure equals to 10 bar. If the dryness fraction is X equals to 0.9, that means it is wet steam. That means 90% of the water has converted to steam. What will be the value of H of that steam? The value of H means the total heat. The total heat means enthalpy. Okay. So first of all, what is the equation for the wet steam? Can anyone help me? It is the H equals to the sensible heat, HF,
Plus latent heat.
plus latent heat. And the latent heat for the wet steam is dryness fraction multiplied with the latent heat, isn't it?
Yes, sir.
Okay. Here, my student, in this equation, the value of X is already given 0.9. You can easily see, isn't it? So we need this sensible heat and we need this latent heat, sir. From where we will get this value? It's very easy, my student. We have one value given, that is pressure. That is pressure equals to 10 bar. So my student, there will be a steam table given. This is a steam table. This is called a steam table. So here there are some parameters. First of all, get to know what are those parameters. The first column is the pressure column. The first column is the pressure column. You can see the pressure value 1, 1.5, 2, 2.5, 3, 3.5, 4, 5. The table is longer. So the first column is the pressure column. The second column is the boiling temperature. The boiling temperature at that point, at that pressure. So you can see the boiling temperature changes with the pressure. Okay. We need these two columns. Then we will jump to the fifth column, HF. HF, my student. So this HF is the sensible heat. The fifth column is the sensible heat. Then we'll jump to the seventh column. R, basically here, R is the HFG. That means the latent heat. Okay, R is the H of G. That means the latent heat. So the fifth and seventh column are the sensible heat and latent heat. So the fifth column is the sensible heat and the seventh column is the latent heat. So we only need these four columns of this steam table. So come back to the question that we need sensible heat and latent heat. What was our pressure value? In the example, what was our pressure value?
10 bar.
10 bar. So come to the point, this is 10 bar. Okay, so we will directly go to this 10 bar line, and the first value we'll get, this is the sensible heat value, 763, and then we go the 7 column, 2014 or 2015. This is the latent value. So from this steam table we will get the sensible heat and we will get the latent heat. Remember, this steam table has two characteristics. One is the sensible heat and the latent heat starts from 0 degrees Celsius. Okay, it calculates from the 0 degrees Celsius, not from 10 degree or 20 degree. The sensible heat is from 0 degrees Celsius, and also it is for 1 kg. All these value are basically whatever the value you can see here. We have to fix the weight, so it is the mass, so it is basically for 1 kg. So remember this, the sensible heat, because we know that the heat starts from 0 degrees Celsius. So if we are told to 20 degrees Celsius in the next example, it will be different. So this table is from 0 degrees Celsius and the mass is 1 kg. Okay, so now come back to the previous slide. We have, so you can see that, my student, it is written here. So this type of mathematics are very easy. You have to get the value from the steam table. So at P equals to 10 bar from steam table, the HF equals to 762.81 and the HFG is equals to 2015.3 kilojoule. So these two value we are getting from that steam table. Okay, so now put this value into the equation. You will get whatever the value you will get, that is the total heat of the system. Clear? Is it clear, my student?
Yes, sir.
Yes.
Value we are basically getting from the steam table. Okay, so now we move forward. It will be very easy for us. You see, first of all, in the second mathematics, it is told that calculate the enthalpy of 1 kg of steam. Calculate the enthalpy of the 1 kg of steam at a pressure of 8 bar and a dryness fraction of 0.8. Can anyone tell me which steam it is? You know that we have 3 types of steam. Can anyone tell me which steam it is? My student? Okay, I am telling you. Here the steam is not told, but you can see the dryness fraction value. So in which steam the dryness fraction value is given?
Latent.
No. Basically, my student, for the wet steam,
Wet steam.
the dryness fraction. So basically, it is told the wet steam. So we all know the wet steam equation, HF plus X into HF okay, and the dryness fraction is X equals to 0.8. The pressure value is given, my student, 8 bar. So at 8 bar we need this sensible heat and latent heat. So these two value from where we will get? We will get from the steam table. So let's go to the steam table. At 8 bar, you see that this is the 8 bar, my student. So if I go to the 8 bar, this is the sensible heat and this value is the latent heat. Clear? So they are basically taking the sensible heat and the latent heat from the graph. So let's get back to the slide one more time. So basically we are taking the value from the steam table and put this value into the equation. We are getting this. Okay, so this is from 0 degrees Celsius, my student. The sensible heat, we are the 721. This is from the 0 degrees Celsius. Now, interestingly, we are told in the next line that how much heat would be required to raise 2 kg of steam from water at 20 degrees Celsius. It's very interesting. first of all, remember the chart is for 1 kg, only for 1 kg. So however, when it is given 10 kg or 5 kg or 8 kg, first of all you always calculate for 1 kg, then we multiply 2 3, because the relations of water is linear relation, so we can just multiply, no problem. So if it is told 10 kg or 20 kg, no matter, you first of all find out for 1 kg, then you multiply for 2, whatever the value we are getting, then we multiply by 2. So interestingly, you see that here how much heat would be required to raise 2 kg of steam from water at 20 degrees Celsius. Till now we are using the steam table that is given us from 0 degrees Celsius. See, this is 0 degrees Celsius. So the total sensible heat value we are getting from the diagram, this is the value. Okay, but now we are told is from 20 degrees Celsius. So can anyone tell me the value from 0 degrees Celsius is bigger, or value from 20 degrees Celsius will be bigger? 20.
Yes, sir.
No, I'm not talking about 0 degree and 20 degree. I'm talking about from 0 degree we are converting from 0 degree to 100 degrees Celsius of water. Okay, so we need to give heat, that is sensible heat. But another case, now your water is 20 degrees Celsius, now you give heat and make it 100 degrees Celsius. Which heat value will be bigger?
স্যার 0 থেকে 100 এ নিলে এটা বেশি হবে, আর
Yes,
20 থেকে 100 এ নিলে কম হবে।
yes, the Qadi says that, sir, if I convert from 0 to 100, the amount of heat will be bigger. But if I convert from 20 to 100, the heat will remain, and the required heat will be less. Okay, so whatever that we calculated this, my student, this value, the total heat, it is from 0 degrees Celsius. Okay, but we need from 20 degrees Celsius. But there is no direct equation, there is no direct pass. So what we'll do, we have from 0, but we need from 20. So we will calculate from 0 to 20 and subtract this value, then we'll get from 20. Am I clear? From 0 to 100, you are told that from 0 to 100 meter, okay, to get you require 10 seconds, suppose. But from 20 to 100, is it 10 seconds or less?
less than 10 seconds।
Less than 10 seconds. So how can you calculate? So now we will calculate in this way, that we will find out from 0 to 20 that how much time it is required here. Suppose here it is 2 seconds, so we'll subtract from 10 to 2, so the 8 second will be from 20 to 100 meter. So that is the process. First of all, we find out here from 0 to total. Now we will find out from 0 to 20, and we'll subtract the later value to the earlier value. So from 0 to 20, my student, if I want to find out, we know that this is ms del t, that means 4.2 into t, 4.2 into t, and t is the temperature difference. So 0 to 20, what is the temperature difference? 20. Okay, so 4.2 into 20, that means 84 kilojoule per kg. So this heat we have to subtract from this total heat, because it is from 0 degrees Celsius, but we need from 20 degrees Celsius. So that's why, my student, in the next slide you will see the actual amount of heat required for 1 kg, that is, this is from 0 degrees Celsius and this is from 0 to 20. So if we subtract, we are getting from 20 to 20 degrees Celsius. But this is for 1 kg, we require for 2 kg. So we'll just multiply with the 2, we get the value. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay, nice. So the third example is, just a blend of everything we discussed. You can see here, it is said that determine the quantity of heat required. That means the enthalpy to produce 10 kg of steam. Remember 10 kg, but you will always calculate for 1 kg, then multiply with the 10 kg. At a pressure of 6 bar, from a temperature of 25 degrees Celsius. It is not from 0 degrees Celsius, it is from 25 degrees Celsius. And you calculate for wet steam, dry steam, and the superheated steam. So we will go for one by one. So first of all, you all know that whatever the value we will get, we have to, we will get from 0 degrees Celsius, but we will require from 25 degrees Celsius. So first of all, in the last example, just like we calculate from 0 to 25 at first, because we have to subtract this value in every steam. So that's why the total amount of heat already available in the water, that is for 25 degrees Celsius, 4.2 into T. So here the difference is from 0 to 25, that means 25. So 4.2 into 25 kilojoule per kg, so 105 kilojoule per kg. This heat we have to subtract from everyone, from wet steam, from dry steam, or even in the superheated steam. Okay, so first of all, for the wet steam, the dryness fraction is 0.9. So if we go to the, this is for the wet steam, you can here see, my student, that we know that the H equals to HF plus X into HFG, and the value of X equals to 0.9. And these two value from where they have got?
Steam table, sir.
Steam table, definitely. If you go to the 6 bar, if I go the 6 bar, 670.71 and 2087, the fifth column and the seventh column. If you go, you get this value easily. Okay, so you put this value. This is for 1 kg, but is it actual value? This is from 0 degrees Celsius, my student. Okay, but we need from 25 degrees Celsius. Now we will subtract that 105 joule from this, because that is the actual amount of heat. So from this we subtract 105 joule, 105 kilojoule, sorry. So this is actually for 1 kg, but remember our question has given for the 10 kg, isn't it? So absolutely, finally we just multiply with the 10 kg and we are getting our total amount of heat required for that wet steam. Okay, for in the similar fashion, for the dry steam, you know that the equation is HF plus HFG. So if you already find out this value, if you find out if you calculate the value of this two, the previous slide, the 720 670 plus 670 plus 2086, if you sum these two value, you will get the value of. This is the summation of the two value. But my student, this is actually from the 0 degree Celsius. So we require from the 25 degrees Celsius, and now we subtract 105 kilojoule from here. So we're getting actual amount for 1 kg of water. But in our questions, it is given 10 kg of water. So basically we will multiply with the 10 kg. So this will be our total heat of the system for the dry saturated steam. Okay, this is for dry steam. So in the same manner, the manner is same for the superheated steam. This is the equation, my student. These two value we already find out. The specific heat is given in the question. The specific heat is given that is 2.3 kilojoule per kg per Kelvin. The specific heat is given. And the two temperature, one is T superheated temperature, one is boiling point temperature. The superheated temperature is also given in the question, that is 250 degrees Celsius. But what is boiling point temperature, my student? So to find out boiling point temperature, we have pressure 6 bar and we will go to the steam table. Because we know that the second column, in the second column, so 6 bar, you can see that the 158.9. That means 86 we can consider as 9, so 1.8 158.9. so this is the boiling point temperature. So we take this value from the steam table and come back to the here. Okay, so you see that the P equals to 6 bar, so that means the boiling point is 158.9 from the steam table. So we put all this value here, we're getting for the 1 kg, but this is from the 0 degrees Celsius, but we require from the 25 degrees Celsius. So we subtract 105. This is from the 25 degrees Celsius, but it is for 1 kg. So you multiply with the 10 kg, whatever the value finally we get, that is the answer. My student, have you got the process?
Yes, sir.
Have you understood that how we have to use the steam table and put this value basically in the equation, 3 equation? First of all, this 3 equation you have to understand. You have to remember the HF plus X into HFG, HF plus HG, HF plus HFG. This is specific heat CP or S T super minus T boiling point. That is superheated temperature minus boiling point temperature. Okay, so in the same way, you just put this value from the steam table using the pressure value.
Sir,
Yes.
we understand HF and HFG and X, all of them, but how about the CC, sir? The temperature, the TT, we also understand T sub minus TB,
Yes.
but how about, sir, CBSS?
Okay, that my student here, you see that this is specific heat. You see that? Just the representation. You can take the CP as S. It is fixed value. A specific heat. Specific heat is minus student. That is to increase. It is a fixed value for the water. To increase 1 degree Kelvin of temperature for 1 kg of water, it requires a particular fixed heat. Okay, that is for a specific heat for water and a specific heat of steam. So this value is fixed value and it will be, it's a constant value. It's a constant value. It will be given in your example. So specific heat is, even you see that in the example, that it is given that the superheated steam at a constant pressure, that is 250 degrees Celsius, and the specific heat is 2.3 kilojoule per kg per Kelvin. That is CP. Clear?
Yes, yes, sir, understand.
Okay. Any more question, my student?
হ্যালো স্যার, এখানে যে স্যার এই যে 4.2 টি এটা স্যার এই যে 25 ডিগ্রি সেলসিয়াস এর এটার মধ্যে স্যার ফার্স্টটার মধ্যে স্যার 20 ডিগ্রি স্যার, এটা স্যার বুঝতে পারিনি স্যার এখানে স্যার, এটা কিভাবে বের করলেন স্যার?
ফার্স্টটার মধ্যে ফার্স্টের মানে আগের এক্সাম্পলটা?
জি স্যার, ওই যে 20 ডিগ্রি সেলসিয়াস এবং এটার মধ্যে 25 ডিগ্রি সেলসিয়াস স্যার।
এখানে দেখো বলি তো দিছে যে ফ্রম ওয়াটার এট 20 ডিগ্রি সেলসিয়াস, মানে পানিটা 20 ডিগ্রি সেলসিয়াসের পানি, বুঝছো? 20 ডিগ্রি সেলসিয়াসের পানি, আর পরেরটাতে বলছে 25 ডিগ্রি সেলসিয়াসের পানি। এই যে পরেরটাতে দেখো কি বলছে, পরেরটাতে বলছে যে ফ্রম এ টেম্পারেচার অফ 25 ডিগ্রি সেলসিয়াস, মানে 25 ডিগ্রি সেলসিয়াসের পানি তোমাকে বলেই দিছে। কিন্তু আমরা যদি নরমালি চিন্তা করি 0 ডিগ্রি সেলসিয়াসের পানি থেকে শুরু করি, কিন্তু এরা আমাদের প্রশ্নে বলছে যে তোমাকে 25 ডিগ্রি থেকে শুরু করতে হবে। সেই ক্ষেত্রে তোমাকে কি 4.2 ইনটু 25 দিয়ে গুণ করতে হবে। এখন এই সূত্রটা কোত্থেকে আসলে আমি আগেই বলছি, যদি তাও সূত্র না বুঝো, এমএস ডেল টি, বুঝছো? এমএস ডেল টি। এখন এম হলো, যেহেতু আমরা এখানে 1 কেজি ধরে নিতেছি, তাহলে এম এর ভ্যালু 1, এস হলো তোমার হলো স্পেসিফিক হিট, তাহলে এটা হলো 4200 জুল। ওইটাকে যদি আমি কিলো জুলে হিসাব করি তাহলে 4.2 কিলো জুল, আর ডেল টি মানে হলো টেম্পারেচার ডিফারেন্স, তাহলে 0 থেকে 25 ডিগ্রির মধ্যে ডিফারেন্স কত হবে? 25 হবে না? 0 থেকে 25 হলো 25, আর আগেরটাতে 20 বলে দেওয়া ছিল 20, যদি তোমাকে এখানে 30 বলে দেওয়া থাকে তাহলে 4.2 ইনটু 30, এটা ডিপেন্ড করে তোমার এক্সাম্পলে টেম্পারেচার কত দেয়া আছে। বুঝতে পারছো?
জি স্যার বুঝতে পারছি স্যার।
Anyone else? Do you have any question, my student?
স্যার
Yes.
স্যার এই যে ম্যাথ গুলা এখানে যে মোট মানে টোটাল টেম্পারেচার বের করে, তো আমরা তো স্যার ইন্টার লেভেলে যেটা করছি এমএস ডেল থিটা দিয়ে ওইখানে সরাসরি করছিলাম,
হুম
বড় ছিল বাট একটা থেকে আরেকটা মাইনাস করি, ওইভাবে স্যার মিলানো যাবে না এটা?
ওইভাবে মিলানো যাবে।
স্যার আমি চিন্তা করতেছি বসে বসে যে ওইভাবে তো মিলালে হয়, তো সমস্যা নেই।
হ্যাঁ হবে না কেন, ওমা ওগুলো তো হবেই, ওটা হবে না কেন, কিন্তু এখানে যা শর্টকাট করে করে দেয় আর কিছু
জি স্যার বুঝতে পারছি,
ওভাবে করা
ওইটা
যাবে,
গুলো বড়
সমস্যা নেই।
হবে কারণ
হ্যাঁ
তিনটা আলাদা আলাদা করে করে নিতে হবে।
হ্যাঁ দরকার নেই।
বুঝতে পারছি।
Anyone else, my student? Okay, you can give your role in the chat box. I have given the recorded class lecture of this same class, exact same class. Shuaib, is it okay in the same class?
Yes, sir. It's
Yes.
same class, sir.
It was the same class. So
Yes,
if
sir.
you see that video at first time and then come to this today's class, it was, you can tell before me,
Yes, sir.
so that's why I told you that, my student, if you come if I cannot take the direct class for some reason, not for my personal reason, it was from the department point of view. So that's why I have given that class lecture video. Okay, no problem. I think that today you were very much clear that whatever the topic was. Okay, let me take the roll number. Roll 33, roll 23, roll 16, roll 28, roll 7. Please everybody give your roll number. 27, roll 13, roll 19, roll 22. Anyone else?
35, sir.
35. Anyone else? I don't think so. Total 10 students. I got the total 10. Sorry, anyone? It's my voice.
No, sir.
Okay, my student, that's it for today. See you in the next class, and I will give you the video lecture and the class lecture in the Google Classroom as soon as possible. Okay.
Inshallah.
Thank you. See you the next week. Okay.